Welcome to A-Level and AP Physics. In today's lesson, we will discuss past paper questions on mechanics from Module 2022, Paper 2. In this class, we will discuss different topics from mechanics, and we will try to understand and try to improve our conceptual understanding of those topics by solving past paper questions. So watch the video carefully and try to improve your conceptual understanding of mechanics. Let's study together. Let's improve together. In today's class, we are talking about June 2022, and total time for this exam is 1 hour and 15 minutes. You need to answer all the questions on this paper, and total mark for this paper is 60. On the second page of your exam paper, some data is given to you. Means values of some important constants are given. If you need value of any constant, you can come to second page of exam paper and you can find value of constant. So this is very important. You need to be clear that values of constants are given to you. On second page of exam paper, you can also find some important formulae. But these formulae are not all the formulae you need for AS physics. But these are some important formulae about different 7 topics, but you need to understand how to derive rest of the formulae, or you need to remember. For question number 1, it is given to us: a solid metal sphere has a diameter of 3.42 plus minus 0.02 centimeters and a mass of 67 plus minus 2 grams. We need to calculate density of this metal, but our answer has to be in grams per centimeter cube. We need to calculate density for this question. Very straightforward question, or we can say is a very basic question. You need to understand how to calculate density. Density is simply equal to mass over volume. So we can use capital M for the mass and we can use capital V for the volume. For this question, mass is given to us. Value of mass is 67 grams, but volume is not given. Diameter of the sphere is given to us. So first of all, we can calculate volume. Volume of sphere is equal to 4 by 3 pi r cube. In the question, we have diameter, so we have to convert diameter into radius. Diameter is 3.42 centimeters. We need to divide diameter by 2, so this is radius. Now we need to take cube of this. If we take cube of this and we solve for volume, our answer will be 20.9 centimeter cube. So this is volume of sphere. Now simply we can plug in this value here. So this is 20.9 centimeter cube, and we can solve for density. Our value of density will be equal to 3.2 grams per centimeter cube. So this is value of density. So this is our final answer, and this is how you can calculate density. For this question, we have 3 marks, and the first mark will be given to you if you have written this formula. So it's very important that you write down all the steps. You can see in this case, if you simply write down the formula, you will get 1 mark, and the second mark you will get if you have got right value of volume. So this is the second mark, and the last mark is the answer mark. If you have got the right answer, you will get this mark. So this is how marks will be awarded. From this question, you need to understand, you need to write down all the steps all the time. You can see if you only write down the formula, you will get 1 mark. So always write down all the steps. For part B, we need to determine the percentage uncertainty in the density. But for this question, we have diameter of the sphere and we have mass of the sphere. And we have also discussed about density, that density is equal to mass over volume. Now we need to look at these quantities. As these two quantities are divided, so the percentage uncertainty in rho will be equal to percentage uncertainty in mass plus percentage uncertainty in volume. Percentage uncertainty in volume. Now first of all, we need to understand volume is equal to 4 by 3 pi r cube. For this question, we have diameter, so we can rewrite this one. So we can write down in terms of diameter. So radius is equal to diameter divided by 2. We need to take cube of this. So if we simplify this one, we will get this is 4 by 3 pi d cube divided by 8. We can further simplify this one. We can cancel this 4, and here we will get 2. Means simply we divide 8 by 2 and we can cancel 4. So we left with pi by 6 and this is dq. Pi is a constant and 6 is also constant. So there is no uncertainty in constants. So it simply means that we need to consider percentage uncertainty in diameter. As diameter, it has power, means it has exponent. So exponent has to come in front of percentage uncertainty. So here we need to consider percentage uncertainty in diameter. This is the main concept what we need to answer this question. Now simply we need to calculate percentage uncertainty in mass and percentage uncertainty in diameter. In order to calculate the percentage uncertainties, we need to write down absolute uncertainty of mass divided by value of mass itself, and we need to multiply this one with 100 because this is percentage uncertainty, and we will use the same method for diameter. So we will have absolute uncertainty of diameter divided by value of diameter, and this one we need to multiply with 100 because this is percentage uncertainty. Now simply we need to plug in values. So we have absolute uncertainty for mass, that is equal to 2 divided by 67. We need to multiply this one with 100 plus 3 times we have absolute uncertainty of diameter, that is 0.02, and we need to divide this one by value of diameter, that is 3.42, and we need to multiply this one by 100 because this is percentage uncertainty. If we simplify, we can get value of percentage uncertainty in density. So this is percentage uncertainty in density. Percentage uncertainty you can write up to 2SF, or simply you can use 1SF. It is acceptable up to 1 or 2 SF. So in this case we will write down our answer up to 2 SF. So this is the final answer. This question has 2 marks. The first mark you will get if you have written this step. If you have written this step, you will get 1 mark. And the second mark you will get if you have got the right value of percentage uncertainty. For question number 2, it is given to us: an archer releases an arrow towards a target at a velocity of 65 meters per second and at an angle of 4.3 degrees above the horizontal, as shown in figure 2.1. When arrow is released, the tip of the arrow is at a horizontal distance of 70.0 meters from the target and 1.66 meters above the horizontal ground. The arrow hits the center of the target. We can assume for this question that air resistance is negligible and that all the mass of the arrow is at its tip. For part A, we need to show that the time taken for the arrow to reach the target is 1.08 seconds. In this question, we will treat arrow as a point mass because in this question, it is given to us all the mass of the arrow is at its tip. So simply we can treat this arrow as a point mass. Now we need to understand the motion of this arrow. So the motion of this arrow is like projectile motion. So this will go first of all up, it will reach the maximum height and then it will start moving downwards. So the motion will be somewhat like this and it will hit the center of the target. We can also draw horizontal line here so you can see this motion in a very clear way. So this is what you will see how this arrow will move. For this question, we need to calculate the time taken. In order to calculate time taken, we can only take its horizontal motion. For horizontal motion, horizontal displacement is given to us. Then also we can resolve this one into its components, means the velocity of arrow we can resolve into its components. Velocity of arrow is 65 and angle is 4.3 degrees. So it has horizontal component and it also has vertical component. So the horizontal component in this case we can write down that will be equal to 65 cosine of 4.3 degrees. Horizontal displacement is given, but it is also given to us there is no air resistance. So it simply means that there is no acceleration along horizontal. So AX is equal to 0. So simply we can say horizontal displacement means SX, that will be equal to simply UX times T, means the total time taken. We need to calculate total time taken. So we can write down horizontal displacement displacement divided by horizontal component of velocity, initial velocity, and that component will stay constant all the time. Now simply we need to plug in values. We have horizontal displacement, that is 70.0 meters, and we have horizontal velocity, horizontal component of initial velocity, that is 65 cosine of 4.3 degrees. If we solve this one, our answer will be about 1.08 seconds. And this is what we need to show, that t is equal to 1.8 seconds. And this question has 2 marks. The first mark you will get if you have written this formula. So you will get 1 C mark. And if you have got the right answer, you will get second mark, and this is A mark. For part B, we need to calculate the height of the center of the target above the ground. It simply means that at this point we have center of this target. We need to find out this height. Let's say this height is equal to small h. And this height, this one, let's say this is equal to capital H. So this height is given to us, and this is equal to capital H. Now we need to consider motion of this arrow. We have already discussed, so let's redraw that. This arrow, first of all, will go up. It will reach maximum height, and then this will start falling downwards. So this will go like this, and finally this will hit this target. We can draw horizontal line. So this is the horizontal line. Let's try to understand how we can calculate value of small h. This is what we need to calculate. In order to calculate h, if we can find out this vertical displacement, then it will be very easy to calculate value of small h. Let's say this vertical displacement is equal to d. Now in this case, we can simply write down capital H. This is equal to d plus h. We need to calculate small h, so we can write down this will be equal to h minus d. Value of capital H is given, that is equal to 1.66 meters. Now, if we can find out value of small d, means the value of the vertical displacement, then we can find out value of height. Now we need to find out value of d. In order to find value of d, we need to consider projectile motion. If we look at this point, we have the initial velocity, that is 65 meters per second, and this arrow is at an angle of 4.3 degrees. So it has two components, horizontal component and it has vertical component. We can say this component is uy. If we need to find out this value of t, we will consider motion of this arrow from this point to this point. But we have already calculated time taken from here to here, and that time taken t was equal to 1.08 seconds. We have the initial velocity, we can write down uy, that is equal to 65 sine of 4.3 degrees, and we have value of a, that is equal to 9.81 meters per second per second. This velocity is vertically up, so we can draw arrow here. This is up and this one is down, so we can draw arrow here down. We need to find value of t. In order to calculate value of t, simply we need to consider vertical motion. So let me use different color and we can answer this question. So we are talking about vertical motion only, so you have to be very clear about this one. We are only talking about vertical motion. That's the reason acceleration is equal to 9.81. Now in this case, we need to take one direction as positive. So in this case, we will take up is positive. So the value of displacement will be negative. We need to take up is positive. If we take up positive, this value, this will be positive and this one will be negative. So simply we can use in this case S is equal to ut plus 1/2 at square. S we need to find out, so that is equal to d. U initial velocity is given, that is 65 sine of 4.3 degrees, and this is multiplied with 1.08 plus we we have 1 by 2, and A is negative 9.81. This is negative because this is down. We have taken up is positive, and value of time we have, that is 1.08 square. Now we need to solve this one for D. If we solve this one for D, we will get answer is 0.46 meters. That this answer will be negative. Why this is negative? Because displacement is downwards. We have taken up is positive. So value of displacement, what you will get, that one will be equal to negative 0.46 meters. Simply you need to plug in this value here. So this is 4.6 meters. We are talking about height, so that's the reason we have taken positive here. So the final answer in this case will be equal to 1.2 meters. So this is value of the height, and this is how you can calculate. If your concept of projectile motion is clear, you can calculate very easily. I hope this is clear to you. If you have any questions about this one, just leave your questions in comments. This question has 3 marks. The first mark will be given to you if you have written this one. So this is the first mark. If you have written this, you will get first mark. And the second mark you will get if you have got the right value of displacement, means right value of D. So this is the second C mark. And the last mark is answer mark. If you have got the right value of height, you will get the last mark, means you will get answer mark. This is how marks will be awarded to you. For part C, we need to consider energy changes, and we need to state and explain how the final kinetic energy of the arrow as it hits the target compares with its initial kinetic energy after release, soon after it is released. A numerical calculation is not required. This question is simply about conservation of energy, or simply I can say this is about conservation of mechanical energy, because in this question there is no air resistance. Air resistance is negligible. So simply this is about conservation of mechanical energy. Let's try to look at motion of this arrow. We have already discussed this arrow. First of all, it will go up, it will reach the maximum height, and then this arrow will start falling downwards. So the motion of the arrow will be somewhat like this. We can also draw horizontal line here at this point. For this question, simply we need to compare the final kinetic energy with initial kinetic energy. It simply means that at this point arrow has certain kinetic energy. We can say this is initial, and when it hits the center of the target, it has certain kinetic energy. That one is final kinetic energy. Now if you look at motion of this one, when this arrow is moving up, arrow will gain GPE, means its gravitational potential energy will increase, but its kinetic energy will decrease. So simply we can say kinetic energy decrease. In this case, kinetic energy will be converted into GPE. But when this arrow will start moving downwards, means when it will start falling, in that case GPE will decrease, then GPE will be converted back into KE. So when arrow will reach at the same level, at the same height, kinetic energy at this point, let's say this is kinetic energy 1, this will be equal to initial kinetic energy. But after this one, you see arrow is still falling, mean arrow is moving downwards. So as arrow is moving downwards, gravitational potential energy of this arrow will decrease. As this energy is decreasing, it means this energy will be converted into kinetic energy. So in this region, simply we can draw arrow here. In this region, kinetic energy is greater than the initial kinetic energy because gravitational potential energy is decreasing. So simply we can say that kinetic energy final, if I compare with this one with initial, so the kinetic energy final will be greater than kinetic energy initial. But if we compare GPE final with GPE initial, GPE final will be lower than GPE initial. Or simply we can say in this case GPE has been decreased, that kinetic energy has been increased, that the total energy is conserved. So that's all what we need to understand. So let me show you how you can write down your answer. In order to write down a proper answer, you can write down your answer like this. the first point you can say in this case GPE has decreased, and this is 1 mark, means M mark. And the second mark is if you have written total energies conserved, so kinetic energy has increased. So if you have written these points, you will get 2 marks. For this question, you have to mention gravitational potential energy has decreased. If you will write this one, you will get the marks. If you will not write down gravitational potential energy has decreased, you will get 0 marks for this question because this is M mark. If you simply write down kinetic energy has increased, so this can be the statement, but you also need to explain, state and explain. So explanation is must. If your explanation is wrong, you will not get any marks.